Hello, today we're going to do some performance testing of the UDM Pro MAX firewall, and it's a device made by Ubiquiti. It's the highest end of the UDM Pro line. They do have one higher end device, their enterprise device, but it's a very capable firewall that you can use for a lot of different applications. It is able to both run the UDM Pro software for your firewall as well as things like access and protect. It has two hard drive bays. So you can put in hard drives for the Protect camera system. I actually ran the Protect system on my UDM Pro Max for a while before switching it to the dedicated UNVR Pro, only because I wanted to have a lot more cameras. So it's a super versatile unit. Most importantly is that it has a 10 gig interface for inbound, the WAN interface for your internet, and then also a 10 gig interface for the inside network. And that means that not only can you support up to 10 gig external internet connections, but that 10 gig internal connection allows you to use this as your VLAN to VLAN router and have that be connected to your infrastructure over 10 gig. So it's a relatively versatile box. It also supports, which I mentioned in a previous video and tested, the multi-unit failover where you can have two UDM Pro Maxes and they can be synchronized and one can take over if the second one fails. And then it also has a secondary internet connection that is a 1 gig connection for if you want to have a backup internet connection. Could be for cellular or Starlink. And it will automatically fail over to that connection if the primary internet connection fails. But today we're going to focus on measuring some of the sort of the max performance of the Pro Max unit. And we're going to test a number of different things. We'll test both normal transit from inside to outside, outside to inside. And we'll do that both with the default configuration as well as turning on the enhanced protection stuff, which allows it to do intrusion detection and packet analysis. And so we'll turn those on and measure the differences in performance with those features turned on. And we'll also test the built-in VPN functionality. This supports both OpenVPN and WireGuard, as well as their own VPN technology. And so we're going to test the OpenVPN and the WireGuard and see how fast that is. And then we'll end the test doing some internal VLAN to VLAN testing. So as if you have internal boxes using the UDM Pro Max as your VLAN to VLAN router. And so we'll do a number of tests and see how well this box performs. So for this test setup, I have a UDM Pro Max firewall here that is connected to my outside networks. And then it has a 10 gig connection into a little switch. And that switch has fiber connections that go over to a pair of test servers. So these each have 10 gig fiber connections just dedicated to testing. They also have some internal 40 and 100 gig connections. But this allows me to have one machine on the inside and one machine on the outside and be able to do performance testing. And then also I can swap this over and put both of them on the inside and have one of them on a different VLAN. So that's the gear we're using. So let's dig in and take a look at the performance of the UDM Pro Max firewall. So I have two machines here. The one on the left is effectively inside the network on the LAN side of the UDM Pro Max. And this machine is on the outside. It's on the internet. And we have the machine here, and we have the protections currently turned off. It's a relatively simple configuration. There is one VLAN that's in there. We're going to do some VLAN to VLAN testing later. But otherwise, it's relatively what you would get out of the box in terms of the configuration. And so on the one on the internet side, we're going to run iPerf 3 in server mode. And over here, you can connect to that box. This will do a single TCP connection. And sure enough, we get about 7 gigabit a second. And that is not limited by the firewall. That is limited by iPerf in a single thread. And so we can further this by, let's do 4 connections, and we're going to have ignore the first 3 seconds. So this will do 4 TCP connections going through the firewall, through the firewall's network address translation, and then out to the internet side. And sure enough, we get very close to the theoretical 9.3 some gigabit per second. This is a 1500 MTU network, so standard for what you'd see on the internet. And so sure enough, as you'd expect, the firewall has no problem passing traffic at line rate. Keep in mind that iPerf, by default, is upload. So this is sending to the outside, so sending to the internet. If we add a -R, it'll flip it around, and now it's going to download. This is as if you're downloading from the internet. And we get relatively similar performance, 9.3 gigabit a second, so relatively close to the line rate with this MTU over TCP. So that's nothing really surprising there. You can do that testing with a little more threads, so we have a lot more threads running. And in general, this seems to net out to pretty close to the same numbers, around 9.3 gigabit per second, both inbound and outbound. We can also, let this finish here, we'll go back to 4 threads. We can do bi-directional. So this will run 2 TCP tests, actually in this case 2 per thread, one sending outbound and one downloading. So this will be as if you're uploading at the full 10 gigabit and downloading at the full 10 gigabit. So it's a good test of what the speed will be, and let this run for a few seconds. And sure enough, we look here, the sum is the transmit was around 6 gigabits per second, and the receive side was about 5.58 gigabits per second, somewhere around there. And so this is certainly a limitation in this total speed of being able to transit both outbound and inbound, because if we do the tests individually, we can get about 10 gigabit in each direction independently. But when we're doing them shared, there's a little bit of overlap. In this case, the firewall probably has a limit of how fast it can do packets in both directions. So let's expand this a little bit. So if we go back to our single test here, and we get, like I said, about 9.4, we can go over to the firewall. Let's go into security here. And we could turn on the region blocking. And so let's try, I'm gonna try pinging, let's see, let's try, was it 72, I think is one. 91.72.72.2. So that is a router in the UAE. So the ping time is about what you'd expect. And we can go in here and we can turn on the region blocking. And so we'll select just a bunch of countries here in the beginning to give it a little work to do. And so we'll add those. And so now it's going to look for blocking those regions and do apply changes. And my experience is it takes it maybe 15, 20 seconds for this application to take effect. It varies a little bit. Yeah, it hasn't taken effect yet. And there you go. So now it's blocking traffic to that IP address range, and a bunch of them actually. And this has virtually no effect on performance. We can run iPerf in both directions and get approximately the same speed. You wouldn't expect this to make a big difference because it isn't inspecting it on a per packet, but on a per stream. So when the NAT tables are set up for the outbound connection, it'll look the IP addresses up in the blocked list and block it then. So it's a relatively efficient thing to do, so it doesn't have a big impact on performance. If we turn on intrusion protection, however, and we'll turn that on, and the defaults have everything except for 2 different tests turned on. So we'll turn those on, and this takes a few seconds to do. And if we do the same test, and keep in mind that this is an upload test, this is sending from inside outside to the internet, and most of these detections are for download. So we'd expect to see pretty minimal impact, and sure enough, there you go, we're getting over 9.3 gigabit per second. So hardly any effect at all on uploads, which is not surprising because the filtering is primarily on the downloads. Now, if we go in reverse, now we're going to be downloading from the internet across the UDM Pro Max with these protections turned on. And sure enough, we see 4 to 5 gigabit per second. It does seem to be limited on the speed of each stream, and you'll see what I mean here. We'll let this finish. So this averaged out to 4 gigabit per second. If I increase the number of streams to, let's say, 8, we'll get a little bit closer to that sort of theoretical 5 gigabit a second. And so that number, 5 gigabit a second, that's said for having the protections turned on is in fact reasonably accurate. If you have those protections turned on, generally limited to around 5 gigabit on download, but it doesn't have much effect at all on upload. Now we can go over here and we can turn on the remaining 2 vectors. I think the protocol one, this online games one, has a little more work to it. So we'll turn those on as well. And then we'll let that configure for a second, and we'll go back over here. We'll continue the test. And so this will be, again, an upload. So we're going out the firewall. And we expect to see not a huge difference. You will notice that occasionally the transfer rate is a little bit lower. I think it may be in the middle of making some changes right now, so the box may be a little busy. We'll see what this averages out to be. So 8.96, almost 9 gigabit a second for upload. And then we can do the reverse for download. And of course, this is going through that detection. And sure enough, you're seeing speeds in the order of 4 gigabit a second, 4.3. And so it may be a tiny bit less with those other two vulnerability scannings turned on. But in general, you do get around 5 gigabit a second if you have these detections turned on in terms of download, but of course upload is virtually unlimited. So we're going to turn these back off, and we'll turn off the region blocking. And we're going to try something else that's interesting to see, which is we're going to look at the VPN performance. And so I've created both a WireGuard and an open VPN server on this UDM Pro Max. And so we're going to go over to the machine that's on the outside. So this is like it's on the internet. And we're going to first do OpenVPN. And so we'll start an OpenVPN connection. And this was built with just using the file that's exported by the UDM Pro. So there's virtually no work to do. And so on this side, this is the inside, we're going to run a server. And we'll go back over here. And we're going to make sure we can ping it. And so that's pinging over that VPN tunnel we just connected to. And so now we can run a performance test. So we'll just do one stream to see how it works in the beginning over that connection. And so this is going through the OpenVPN connection that's being hosted by the UDM Pro Max, and then from there to the inside box. And you can see that it's limited to around 300 megabits per second. We can expand this to more threads, and it doesn't really make any significant difference. It does seem like the OpenVPN is limited to around 300 megabits a second. Obviously, this connection is much faster than that. I have it configured such that if you change this to... This is the IP address of the actual UDM Pro Max. I have a port forward that port forwards directly to this machine. So this bypasses the VPN. And so you can see you get an easily 9.3, 9.4 gigabit a second. And so the VPN itself is the limitation. Now, if we go back to the VPN and we go in reverse, so this will be effectively downloading from the outside world over the VPN. And the speed is very similar. So the OpenVPN server is limited to around 300 megabits per second. When it's running on the UDM Pro. And that's really a limitation of OpenVPN, which is known to be relatively slow. So we can go close out that guy. And I also have set up, we can run, I think WG0 is a WireGuard client. So we're going to run that. And we can go back to here and we can try pinging. And so now we're going over the WireGuard interface, this guy here. It's somewhat slow to show active clients, by the way. I don't know why. So now we're going over the WireGuard interface. So we can do the same test here. We'll do this one first. And the WireGuard gets about 1 gigabit per second. So it's significantly faster than OpenVPN, and that's reasonably well known. We can do the reverse test. So this is downloading from the VPN side. So it's an upload from the point of view of the LAN. And we get very, very similar performance. And this data rate here does seem to be limited by the computation in the UDM Pro Max for the WireGuard protocol. If I do bidirectional, click there. The summation is generally relatively close to 1 gigabit. It's a little bit above that. And so we'll let it finish up here. So here, we were doing the receive at 550 and the sum at 861. So you got a little better there, about 8.3, almost 1.3 versus 1.4 gigabit per second. So there's a little bit of extra headroom there going in both directions. But in a lot of testing, I've determined that this does appear to be a limit of what we can do with WireGuard, both with the machines that I'm using here and with the UDM Pro itself. So WireGuard is unsurprisingly lots faster. The fact that WireGuard can get you over a gigabit a second is pretty good. And so if you use WireGuard, I think you can get reasonably good performance from outside VPN sources. We also can, and so if I go here, we can turn down this interface. And I was curious if we, instead of running WireGuard on the UDM Pro, if I, let's stop this here. If I run WireGuard on this machine that's on the inside, so now this would be running a WireGuard server inside your network and just having the Unify box, and you can see it here if I go to security, not routing, there we are, port forwarding. This port forwards on port 51,000, so we can use that for a WireGuard running on this inside machine. So now we're running WireGuard on a machine inside the network, and we can go over here and we can connect using WG1. And so that is connecting now directly from this machine to the machine, just using the port forwarding on the UDM Pro. And we can make sure we're connected. And we are. And so we'll click over here, run the server, and we'll do a test here. And sure enough, we get very similar, actually slightly less performance there. I've done a bunch of experiments with this configuration, and it generally runs in the range of, we could try making it one thread, of 900 to 1 gigabit a second, but never anything more than maybe 1.2 or 1.3 gigabit per second. So having WireGuard run on the UDM Pro works extremely well, and it's probably as fast as you're normally going to get without having a pretty beefy server on the inside and the outside to do the encoding. Yeah, so that's about the same. We can try reverse here. This is going the other direction. And again, that's limited by what's happening over here for the encoding and the decoding on the client side. Okay, perfect. And so one other test that I'd like to do is I'm going to move this box that is currently outside. I'm going to move it inside the UDM Pro. And let's go to networks. I'm going to put it in this .4 VLAN. And the reason is so that we can test VLAN to VLAN routing at 10 gigabit. And we'll see how that works. I'm confident it'll work relatively well, but it'll be good to run the numbers and see if anything's changed in the latest software related to that. So let me switch this over and move this into the internal network. Okay, I've reconfigured this machine over here. Nimble 5 is now on the inside. So both of these are on the inside network, and one of them is on the -4 network and one's on the -1. So they're in different VLANs. And so traffic from one machine to another has to go up from the switch over the 10 gigabit connection to the UDM Pro MAX. And then in the Pro MAX, it'll go VLAN to VLAN routing. So that will pass through the internal zone rules, which currently has allow all, but going from the .4 to the default network. And so over on this side, we can run on a first server, and here we can ping that server first, because it works as expected. And if we run iperf3, let's do a test 1.22. So if we do just a single stream, again, this is uploading, it's sending from this box to this box in different VLANs. So we're going across the VLAN connection, and you get about 5 gigabit a second. And that is really limited by this client. If we instead do, let's do 4 threads. We'll ignore the first 3 seconds. So now it'll do 4 threads, and we get very close to the line rate, 9.2 gigabit per second. And remember, this traffic is going from this machine over to the switch, and then from a switch on the 10 gig connection up to the UDM Pro, and then it turns around in the UDM Pro and comes back down that same 10 gigabit link back into the switch and then over to this machine. And so It's traversing both the switch twice and going up to the UDM Pro and then back. As expected, the VLAN to VLAN routing is at line rate, which is what you'd expect. If we do the reverse direction, again, this is just going from one VLAN to the other. There is no appreciable reason why there should be a large difference. Occasionally, it does have a slightly slower difference, which I think might be related to the iPerf tool. But it runs pretty close to line rate in that case. Now, the real gotcha is if we do bidirectional. Because now we're going to open TCP connections from machine A to B and B to A and try to hammer both of them at full line rate. And what you'll see is that now each one can only get about half of the total bandwidth. And it's not perfectly balanced every time. We'll let it finish up here. I think it'll end up pretty close. Yeah, so the receive side connection got 4.86 and the send side was 4.34 gigabit a second. And that is, of course, because we're now sending from one machine to another. And reminder that when you send, you're going up to the UDM Pro and back down. So you're using up the bandwidth in both of the full duplex 10 gig connections, both send and receive. And then the other direction has the exact same effect, sharing those same things. So the result is that for bidirectional, you really only have 5 gigabits of sort of VLAN to VLAN bandwidth because you're using both the up lane and the down lane from your UDM Pro Max if it's in fact your router. And it's always important to consider that when you think about moving something, like if you want to have a file server on your network and you want it in a separate VLAN from something else that's going to use that storage, it's important to remember that somewhere it has to bridge from VLAN to VLAN. And if in your network, the only thing you have is your UDM firewall, and it's doing all of the VLAN to VLAN connections, then that means all the traffic has to traverse that single 10 gig interface coming in and going back out. And there's only one of them. I think when you do the networks, here we are, you can pick what router is doing the VLAN to VLAN. You can pick third party if you want to have another device do it, or if you were to have bought a, let's say one of their layer 3 aggregation switches, you can have the VLAN to VLAN routing occur on the aggregation switch, which typically has a lot more bandwidth and may have 24 10 gig interfaces. And so it's something to keep in mind, that always know when you do VLANs where the VLAN routing is occurring at. And so these numbers are not unexpected, as you'd think you would get relatively close to line rate in VLAN to VLAN routing. I also did a few tests where I went into the security rules for the internal, and I added, I think, 15 different rules, just sort of interesting random rules that have to be evaluated for that traffic, and it made virtually no difference. It is possible there is some number of rules where you will get a slowdown, but for most practical purposes, adding lots of rules there doesn't seem to have a huge impact in the VLAN to VLAN, in this case within zone routing, so which is good. I think that makes the device perform reasonably well. And so that really is everything we're going to do today on the UDM Pro Max. I think it performed as you'd expect, which is that the 10 gig interfaces can do 10 gig line rate for most things you're going to do. And the WireGuard performance is, as is sort of well known, is really good. And being able to get a gig WireGuard speed is really good. For most internet connections, that's going to be pretty close to what you're going to get anyways, especially if you're over a longer latency connection. So that's it for now.